Hey everyone, my name's Chad. This is a step-by-step guide for Cloudblock, a project that I wrote. I'll follow along with the instructions on the GitHub page and we'll start there. I'll scroll up to playbooks where the standalone deployments are, and then scroll down to the Raspbian deployment guide. I'll be using Raspbian 10. That's the latest version of the Raspberry Pi operating system. Comes generally pre-installed on the Raspberry Pi devices, and I've tested it with a Raspberry Pi 4 and 3. The first step is to ensure your system is up to date. I have a terminal already open. I'm in a remote desktop environment. You could certainly do this with a traditional keyboard, mouse, and monitor, or you could do it over SSH. You'll need the guide to follow along. I'll paste that command in. This may take a moment, especially if you've never updated your Raspberry Pi before and the operating system is very much out of date. My system should be up to date, and it is. Next, we'll install two packages, git and python 3 pip. Git will be used to clone the project, and pip will be used to install Ansible, which is how we deploy the project. And that's the next step. pip3 install Ansible. Paste that in. Give it just a moment to run. Next, we'll have these two commands. These are used to tell your terminal or shell where Ansible has been installed to. It is two commands. Make sure you grab both, paste them in. And then optionally, we reboot the Raspberry Pi. If your system was several months out of date, or you've never updated it before and you just ran that very first command to update the operating system, there may be things like the kernel patches, newer versions of the kernel, newer versions of low-level libraries, and my suggestion would be to reboot the machine now. So go ahead and do so. I've already done it just before I did this video. I don't need to, and I'll continue. The next step is to clone the Git project and then cd into the directory. I'll grab both of those commands. It's a long one. Make sure you grab the whole thing. Paste it in. And you can see now we've cloned and then are in the playbooks directory. That's the same directory we're in our browser. Next, we need to set our variables. This is where we customize our deployment. So grab this entire block of variables. And my suggestion is to open a text editor or notepad, paste them in, and we can use this to edit the variables as we see fit. There is a variable section, so scroll down to that and we can see which each one of these are. First up is DO provider. This is where your DNS lookups eventually end up. So DNS over HTTPS, it's encrypted to this provider, and then this provider performs DNS for you. My suggestion, do some research on, there are many to choose from. OpenDNS is just the default. There are many to choose from. Do some research on these providers. Determine which one works best for you. Some offer certain features. I know Cloudflare is popular. OpenDNS is popular. Not all of them may be available worldwide. And then not all of them have features that you may want. So definitely do your research. It serves your best interest to do so. I'll leave it as OpenDNS. It's reliable, works fine for me. All right, next, DNS no VPN. This is a flag, 1 for true, 0 for false. This is available. My suggestion would be to leave it as 1. That's a traditional Pi hole running at home that allows your local network to use it. Maybe you log into your router and set your DNS to the Raspberry Pi IP address. You would need this to be set to 1, the default. If you set it to 0, only WireGuard connected devices will be able to talk to the Pi hole. So this is like a lockdown method. If you don't need a Pi hole running in your home environment, you only plan on using the service for your WireGuard clients, then you would set this to 0. Next is WireGuard peers. This is the number of WireGuard VPN clients to generate. The default is 10. There's no harm in setting more than you need, and you need 1 per device. You do not want them to overlap. So when we're done, when we run the Ansible playbook, it's going to generate, in this case it's set to 10, it will generate 10 peer configurations. And I would assign peer 1 to my cell phone, peer 2 to my laptop, peer 3 to my desktop, etc. on down the line. So if you've got friends and family that are going to be using the service, maybe set it to a much higher number. I know the upper limit is somewhere around 250. And like I said, there's no harm in having more than you need. I'll go ahead and set mine to 30. Next is VPN traffic. So there are three options. We have DNS, which is the default, peers, and all. DNS is, just as it states, when you're using WireGuard away from home and you turn on the VPN service, only your DNS traffic would go back, routed back to this Raspberry Pi, and then talk to the Pi hole, get the ad blocking, and DNS over HTTPS. All your other traffic would go through your standard remote cell, let's say it's your cell phone, it's your cellular service provider, your mobile carrier, public Wi-Fi if you're on public Wi-Fi. Your other options, we have peers. It's the same thing as DNS, but it also allows you to talk to other devices on the WireGuard VPN. So maybe you've got a desktop at home, you turn on the WireGuard VPN, so it is connected, and you're away from home on your laptop, you turn on the WireGuard VPN. You could have your laptop talk to the desktop via the WireGuard VPN securely. Kind of nice to have. And then last is all. This is the same thing as the other two, except it's all traffic. So even your Netflix traffic, your streaming, your YouTube, you're browsing the internet, all of your traffic gets routed back home to the Raspberry Pi, gets the Pi hole ad blocking, but also all of your browsing is done through it as well. So you have the three options there. I'm going to leave it as DNS. I don't need any additional traffic routed through it. And then lastly, we have the others. This is the Docker IP addresses and the WireGuard network IP address. These are set. I'm not going to change them. I don't have anything that's going to overlap. That's the only reason you'd really need to change them, is if you already have these IP addresses or these subnets in use in your home network, or if this is in a business setting, if you're using these commercially, you'd want to make sure that they don't overlap any other internal networks. And it's 172.18.0/24 for Docker, local to the containers, and then WireGuard is 172.19.0/24. All right, so I don't need to change it. It's not going to overlap anything for me. You'll want to save this, so make a save of this text file, and then copy the whole thing and paste it all into your terminal. Let's scroll back up to the instructions. Next, want to set your own Pi-hole password instead of something randomly generated. I do, so I'll follow this. There are three commands. The first one is make a directory. I'll do that. The second is to set the actual password in a file. And I will go back over here and change the password. So it's some password, and I'll just set it to some password 1. All right, so the password has been set. And then we set restrictive permissions on the file that the password is contained in. If you did not do these steps, your password would be randomly generated, and you would need to view this file to determine what the password is. You can do that via sudo cat, and then the file path. And there you go, you can see mine is some password 1. Or if you ever forget, that is where the password's located. All right, we are good to go. We've customized our variables, we've saved those variables in our text file, and we've generated a password, we've set it. We can now run the Ansible playbook. I'll grab this long command, make sure you grab the whole thing, copy, paste it in, and we will let Ansible install our service. It's going to install any additional packages that are needed. It will start up the Docker containers with our customizations and generate the WireGuard peer configurations, and then give us some output at the end that'll be helpful. I'll wait for it to finish and be back when it's done. Okay, that was pretty quick. Ansible has finished up and gives us a playbook summary at the very end if nothing failed, and we can see that nothing failed equals 0. If you encounter problems anywhere along the way, there is a Discord in the description of this video and on the GitHub page. I will be available at, as well as several community members, and we would be more than happy to help you out or guide you along. If you have any ideas as well, or want to share experiences, feel free to do so in the Discord channel. Everyone is welcome. All right, let's look at this output. We first have the Pi-hole web UI. So here's a URL to the web UI. I'll grab this, open my browser. This is available locally, as you can see in parentheses. And if I go there, we get, your connection is not private. That's okay. That's because we're using HTTPS, or it's secure, but we are using self-signed SSL certificates or TLS certificates. That's okay. That's what we want. We'll hit proceed. And I have a dark reader, so it'll be dark themed. I'll log in and put in my password, some password 1. And you can, we're now in the Pi-hole, you can customize it as you desire. The only thing I would note is under settings here, and then DNS. If I scroll down, you'll see custom 1 and custom 2. These are an IP address, the same IP address for both. This is the Docker container called Cloudflare DDoS, DNS over HTTPS, that is encrypting our traffic to our DNS over HTTPS provider. We can see that, so I'll run, that's a mouthful for sure. I'll run sudo docker ps, and you can see there are 4 containers running. We have the web proxy, that's how we're getting secure to our Pi-hole in the web browser. We have WireGuard, that's the VPN. It's provided to us, by the way, by linuxserver.io, a really nice and well-structured group of individuals that create Docker containers for a very large community. They also do Docker containers for a lot of other projects. So keep that in mind if you're interested in more Docker containerization. linuxserver.io, their website is great. They have a Discord community as well, and they have a ton, absolute ton of very well created Docker containers. So certain shout out to them. I use them specifically for this WireGuard project because I trust them to provide a well-built WireGuard container. Next, we have the Pi-hole container. This is directly from, while I'm at it, I'll mention where these are all coming from. This is the one from the Pi-hole company. So the actual group of developers that create the Pi-hole service, they build and publish their own Pi-hole Docker container. And I'll go back to this one, the web proxy HTTPD. This is by Apache, the well-known group Apache that creates open source software. And then finally, Cloudflare DDoS. This is built by you, by your Raspberry Pi when it's created. The binary that's running is called Cloudflare D, and it's provided by Cloudflare. They build a client that you can use and that we are using to encrypt HTTPS DNS lookups, right? So encrypting DNS from plain text into HTTPS, and that's where this one comes from. So you're actually building this Docker container yourself. If we go down, we can see that we have the web UI for VPN. So if you're on your VPN, you're remote, but you turn on the WireGuard VPN service on your device, whether that's a laptop, a tablet, or cell phone, you can get to the Pi-hole web UI remotely. Just use this URL instead, maybe bookmark it or keep a note of it. In fact, my suggestion would be to grab this entire thing and add it to your notes. So I'll do that. Paste it in and save it there. So keep that saved. So you've got your set of variables, and you've got your output from the playbook, from the Ansible playbook. All right, what do we have next? We have DNS local. So remember, we set DNS no VPN to 1. That means your local devices can use the Pi-hole for DNS and get ad blocking and encrypted DNS. You could set this in your router and assign it via DHCP when devices join your network. That would be just fine. Next, we have the WireGuard client files, and we can run this command to see them. I'll copy this, paste it in. And there are, what was it I set, 30? Yep, so there will be 30 peer configurations, and there we go. So there's peer 30, for example. Keep in mind, you want to not overlap your peer configuration. So if you assign peer 1 to your laptop, peer 2 to your cell phone, etc., maybe make a list or keep that in your notes as well, right? So maybe down here, I've got peer 1, my cell, peer 2, my laptop, etc., just so that they don't overlap. If you were to have both of them, if you were to have, let's say your cell phone and your laptop both use peer 1, they try to sign on, likely what will happen is either one of them will work, the other one will not, or neither of them will work. So keep that in mind, don't overlap. This is where the files are located on your Raspberry Pi. So I ran that ls command and we get a list. What we could also do is view the files. So there are 4 files per peer. The ones that you'll be interested in are the .conf and the .png. .conf would be used for things like the Mac client, the Windows client. There's a Linux client as well. I think it's for Ubuntu or GNOME specifically. And then the PNG, which is a image, that is for cell phones, tablets, Android or iPhone, where they'll scan the QR code that pops up on the screen from the PNG file, and that will import the VPN configuration onto that device. And we can see the conf. I'll give you an example. So I will cat peer, peer1, peer1.conf. And there we go. We can see this is private, so this would be considered a password. You wouldn't want to expose this normally, but peer1, there's my conf for that. If I look at peer2, I can see that one as well. And then for the PNG files, you could use your file explorer. This is one option. There are 2 options, and I'll show the other option in just a moment. So let me browse to this one, this peer9. And there is peer9.png, and there's the QR code, right? So if I assign peer9 to a cell phone, I've got the WireGuard app installed on the cell phone. There's an option, scan QR code to add VPN. My camera would activate, and I could point it at that QR code, and then my device has been assigned to peer9. All right, if you are in a non-GUI, non-graphical environment, and you need those QR codes, this is really cool. Let me go back to this. We can run sudo docker logs WireGuard and see the QR codes in text representation, which is really cool. So I'll run that. And if I scroll up, you can see there's the QR code for peer 30, before it, peer 29, peer 28, etc. And you could do the same thing, right? So you could scan this with a phone or tablet with the WireGuard app. That about wraps it up for setup. I'll read it one more time. Save this. It's a copy of your variables, a copy of the output from the Ansible playbook, and maybe also a list of which peers are which devices so that you don't overlap any. Right, so keep a copy of that. Let's go back to the README, and there are a couple more extras. So I'll scroll down here. To use the WireGuard VPN remotely, so like let's say you leave your home, you're no longer connected to your home network, you will need port 51820 open and forwarded to your Raspberry Pi, right? So if I look here, my Pi-hole web UI local, this is my local IP address on my home network. I use 192.168.0/24. All of my devices are in that. And my Pi-hole specifically has been assigned .7. I use DHCP reservations to make sure that my Raspberry Pi always gets the same IP address on my local network. And that way I can set up port forwarding. It is port 51820 UDP. I should be specific. I'll update that in the README. You'll need that forwarded to your IP address for your Raspberry Pi device. All right, let's keep going. Want to reach the Pi-hole web UI while away. I've noted that already. That's this URL. If your public IP address changes, oh, this is a really good one. So if I run this again, where we looked at the conf file of one of the peers, you can see the endpoint IP address. This is my public IP. It would be your public IP address. If your public IP address changes, you might, or especially if it changes often, you might want to, on your device, whether that's a Windows, Mac, your iPhone, your Android, you can edit this value. So if your public IP address changes, you could go into your devices and change it. You could also set it with dynamic DNS. So if you have dynamic DNS running at home, where you have a DNS name that points to your IP address, even if your IP address changes, you could also set that value. You'll need to do it on your clients though, right? After you import the configuration, go in and edit and change the IP address to your dynamic DNS name. certainly could be handy. You could also deploy Cloudblock in the cloud, right? So this is just for Raspberry Pis at home. Keep in mind, there are other deployment methods, and you can deploy it in any of the clouds, any of the major ones. So I've got Azure, AWS, Google Cloud, and Oracle Cloud, and there are free options, especially for Oracle Cloud, which is really nice. And Google Cloud is, I would say, free or 99.99% free. You may see a few cents worth of charges, and all of them offer a free trial, at least for a limited amount of time. So you could try all 4 of those cloud providers. Next, your Raspberry Pi, is it using DHCP and receiving Pi-hole DNS, creating a non-working loop? So if we were to go into a router and set the DNS that's handed out to the Pi-hole, you would, and your Raspberry Pi gets its IP address via DNS, you may end up in a loop where your Raspberry Pi operating system points its DNS at the Pi-hole, and then let's say you were to ever try to run updates or get updates, you're kind of creating a loop where if the Pi-hole service is down, your Raspberry Pi is down, and you won't be able to fix the machine or get it up and running or update it if you're running updates. So we can fix that. We can break that loop with a few commands here. The first command is to back up your DHCP client configuration. I've done that. Next, we disable DNS via DHCP. So this tells the operating system, the Raspberry Pi operating system, Raspbian, not to use the DNS that comes with DHCP. So my router gives out an IP address to my Raspberry Pi device, and it gives it a DNS IP address to go along with it, which is the Pi-hole container. What we just did is told the Raspberry Pi operating system to ignore that DNS IP. We'll use a hard-coded DNS. So here we go. Next, we set a hard-coded DNS IP address. I've already done this, so I'm going to skip this step, but you'll notice here, I'll paste it in so you can see it, that it's set to 1.1.1.1. You could change this to another DNS provider. 1.1.1 works fine for me. You could use Quad 9, Quad 8, whatever it is that you so desire. You could set that for DNS. And then once you're done, to activate the change, if your Raspberry Pi is wireless, you would run this command. If your Raspberry Pi is wired, you would run this one. This will just turn off the connection and turn it back on very briefly. If you're using RDP or SSH, it will take just a moment. Be patient, and then your connection should be reestablished. In fact, I'll do it now. I am wireless. I'll paste it in. And you can see my screen has become unresponsive, but if we give it just a second, it will be back. Maybe. There it is. Okay. And how do I update my containers? Okay, so we've got everything running. We've broken that loop so that we can set DNS for all of our devices at home except for the Raspberry Pi operating system. Let's say it's a month from now and there's an update from the Pi-hole team. They have a new update out, or you want to update the WireGuard Docker container. Those instructions are here. So my suggestion would be to review the Pi-hole and WireGuard container update instructions from the developers themselves, right? So Pi-hole puts out instructions, WireGuard, linuxserver.io puts out instructions on how to keep the containers up to date. Essentially what you do is you remove the containers and then reinstall them. We do that. Cloudblock follows those instructions, but it's good to know the source of the information on where that came from. So we'll do that. The first thing we'll do is be in the playbooks directory. We already are, but if it were a month from now, we may not be. So I'll cd into it. We git pull. This will update the project if there have been any updates. If I've made any updates to the GitHub project, git pull would see them. So you would see some changes here. Next, we set our customized variables. This is where the text file comes in handy, because you likely want the same variables you had before. So I'll copy these, paste them in. Next, we remove the old containers. So again, there were 4 containers. We'll remove all of them. The service is down until Ansible completes. All right, all of the containers have been removed. We rerun the Ansible playbook. It's a long command again. Copy, paste, and we'll give it a moment to run. This will set those containers back up, customize just how we had them before, and it will keep our old data. So things like if you did any Pi-hole customizations, like add an add list, or you've got all your peer configurations already set up for all your devices, all of that information is saved. This is simply updating the container code for those 4 containers, including Pi-hole and WireGuard. Okay, it is complete. The containers are up to date. And if I run sudo docker ps, I can see 40 seconds to about a minute ago, all of the containers have respawned. That's about it, everyone. I hope you enjoyed the video. I hope you learned something. Take a look at the code if you're interested in Ansible. Take a look at the other deployment options if you're interested in running services in the cloud. If you're interested in Terraform and using Terraform to automate deployments of services in the cloud. If you have any questions, comments, ideas, concerns, you want some help deploying the service, or you run into a problem, use the Discord channel. That is the best way to reach me. I often have it open, and there's a community of other folks that have deployed the service as well. They'd be more than happy to help or discuss things related to the services. Description of this video has a link. The GitHub page has a link. Thank you very much. Take care and have a great day.